It's Mr. Long here. I'm doing a screencast to go over sketching simple rational functions where the top of the rational function is linear and the bottom of the rational function is linear. So we have to remember that really we're just graphing fractions, so this is fractional functions. And we have to think about some basic concepts. So the first thing we're going to address is end behavior. So what happens when x gets really big? So let's go down and actually start going through this. So the first thing we want to think about is what happens to the value of y if x gets really huge. So for example, what we're going to do is we're going to let this x value here and this x value here be a huge number, like 1,000, 1,000,000, 1,000,000,000. But when I think about this, how big is 8x compared to 8 if x is 1,000,000, right? So 8 times 1,000,000, that's 8,000,000. So that's 8,000,000. And then I would have on the bottom, I'd have negative 2,000,000 plus 5. Well, negative 2,000,000 plus 5 is really just negative 2,000,000. 8,000,000 plus 8 is really just 8,000,000. So then I'm left with 8x divided by negative 2x. So the x's divide out, and the only thing I'm left with is 8 divided by negative 2. So that means that y approaches negative 4. So when x is at a large number like 1,000, 10,000, 1,000,000, 1,000,000,000, the y value is getting really, really close to negative 4. So the line is in fact horizontal. So we call that a horizontal asymptote. So there's a horizontal asymptote at y equals negative 4. And that's end behavior. Again, that's what happens to the fraction when x gets to be huge. Okay, the next thing we're going to talk about is division by 0. Okay, so what happens really close to the location where the division is 0? So we know, look at what I've just highlighted there. When I'm dividing by a number that's really small, my answer makes a fraction, the quotient, which is the answer to the numerator divided by the denominator, that makes the answer really big. So 0.001, in this case, goes into 1 1,000 times. So the first thing I want to do is figure out what makes, and by the way, I don't think I mentioned this at the start, what makes the bottom worth 0. Like, what I didn't mention is which the function is. I mean, I worked with it in the first part, so obviously you know. But anyway, 8x plus 8 divided by negative 2x plus 5. Well, if I want to make this fraction worth a lot, then what I can do is make the bottom worth a really small amount. So the first thing I do, what's the x value that makes the bottom worth 0? So the bottom is, or the denominator is negative 2x plus 5. And that means right here, folks, that symbol right there that I've just gone over in purple, that means cannot equal. So then negative 2x, I subtract 5 on both sides. And then I get negative 2x cannot equal negative 5. And then I divided both sides by negative 2. So x cannot be 5 over 2, which I think as a decimal works out to 2.5. So since I get since the bottom is 0, I get division by 0. If I had an x value of 5 over 2, that means there's a vertical asymptote, VA, at x equals 2.5. Okay, so now I know the horizontal asymptote, I know the vertical asymptote. Now I need to think about what the intercepts are. The first one is the x-intercept. Okay, so the first one is the x-intercept. And remember that this is a fraction, and the fraction is 8x plus 8 over negative 2x plus 5. Well, if I want a fraction to be worth 0, how do I make a fraction worth 0? So once again, if I walk into a room and there's a piece of lime pie there, and a piece of lime pie, and sorry, you might hear some noise in the background. So there's a piece of lime pie in there, and I really like lime pie. Right now, there's 1/4 of a slice of pie, and once I come in the room, oh look, the pie's gone. So now the question is, how much pie do I have? Well, I have 0 slices out of an original 4 in the whole. So that's worth 0. So if I want a fraction to be worth 0, the top of the fraction has to be worth 0. Well, the top of the fraction is 8x plus 8. So if I want the fraction to be 0, which is, again, it's y equals that, right? So the fraction is the y value. So I want the top to be 0. So that's the numerator. I set the numerator equal to 0. And when I set 8x plus 8 equal to 0, it works out to -1. So that's the x-intercept. Okay, so x equals -1 is the x-intercept. Remember, when you're watching these, it's probably good for you to copy down the example. I should have mentioned that at the start, but copy the example down, pause, rewind, go over things. And it's especially nice to use this when you're doing your own question, so you can be moving through this question as you're trying to do your own question. So you can look at what I do in this example and then apply it to another example. Right? That's probably the best way to use this. Okay, now we do the y-intercept. So what happens when x equals 0, right? So x equals 0 at the y-intercept. And so what I do is I replace everywhere where I had an x, I replace it with 0. So I'm doing f at 0, which means what's the y value when x equals 0? I'm on the y-axis. So 8 times 0 is 8. -2 times 0 is 0. I'm left with 8 divided by 5, which I believe is, well, I can do that as 8/5, or I can divide 8 by 5 in my calculator and get a y value of 1.6. Okay, now I'm going to do what I call the skeleton graph. And the skeleton graph, what it is the skeleton graph is what I do to get all of the key values on the graph. And so the way that I do that is I denote where each key feature is. So remember that we have, oh, that's the x-axis, that's the y-axis. And to start with, we had a horizontal asymptote at y equals -4. We had a vertical asymptote at x equals 2.5. We had an x-intercept at x equals -1. And we had a y-intercept at 1.6. Okay, so those are all the key features on the graph. The x-intercept, the y-intercept, and the two asymptotes, horizontal and vertical, and with their equations. So what you'll notice here is when I go to make this sketch, it's pretty easy to see how it works because I've got to go through those 2 points, right? So since I'm going through the two intercepts at x equals -1 and y equals 1.6, it's pretty obvious that it goes up the asymptote there, and it goes just above the horizontal asymptote there. Well, all of these linear divided by linear functions have the same general shape, so that means that goes there and there. Okay, so that's the general shape. Now, what I really should be doing, though, is verifying. So you're going to see when you're doing your practice questions, there's an asymptote, a little section of asymptote graph, and that's where we verify that the asymptote looks the way it does. And it's really important to do that because as things become more complicated over the next few days, you're going to need a way to figure out which direction the asymptotes go, because they're not going to be as easy as this one. Okay, so let's look at this from a factoring, or from a rules of division process. So I want to figure out whether a calculation results in a negative or a positive. Okay, and I want to do that. I'm trying to see if, like along the asymptote, which side of the asymptote is going to positive infinity, which side of the asymptote is going to negative infinity. So if you look up here, right, where I'm circling green, that's going to positive infinity. Down here, that's going to negative infinity. So I have to figure out whether, when I do my division, when I'm close to x equals 2.5, is the answer positive or negative. And since it's a rational function, right, it's 8x plus 8 divided by -2x plus 5, I get to check and see when I'm close to 2.5 what's happening. And the easiest way to do that, honestly, is with a graph. So I've already figured out that if I'm going to graph these separately, I've already figured out that the x-intercept of 8x plus 8 is x equals -1, and that happens to be the x-intercept of the graph. And then I did the x-intercept of the denominator, -2x plus 5,
and that was x equals negative 2.5, which was the vertical asymptote. So what I need to do is to compare the sign of the numerator and the denominator when I'm close to 2.5, right? Because I'm constantly dividing numerator by denominator. So, for example, if the numerator was negative and the denominator was positive, what would that answer be? Well, negative divided by positive is a negative. Now, what if I had a negative divided by a negative? Well, that would be a positive, right? So here's how we're going to check that. So let's make straight lines that go through each of those x-intercepts. So let's do 8x plus 8. What would that straight line look like? Well, the most important thing for me to do is to graph that negative 1 is that x-intercept, and it's 8x plus 8, so it's like positive, a slope of positive 8, therefore it's sloping up. And then I've got, and that's the numerator, and then I've also got the denominator, and the denominator is negative 2x plus 5, and that had an x-intercept of negative 2.5, so it's out here at negative 2.5. Now this one, though, on the other hand, has a negative slope, so it's going down like so. Does that make sense, folks? So I've got, oh, whoops, positive 2.5. That makes more sense. So I said negative, in fact it was a positive. So I have to go over here to 2.5. And it's sloping down, right? So it's sloping down like so. Okay, and that's the denominator, sorry. So I need to check close to values close to 2.5. So what I'm going to do is, what do I get? So I'm just going to check both sides. So what is it just to the left? So there's my vertical asymptote. So just to the left of the, oh, that's my puppy. Just to the left of the vertical asymptote is a positive for the denominator and a positive for the numerator. What's a positive? And I'm looking at the y values, right? It's above the x-axis, so it's positive. So a positive divided by a positive here is a, I should show it over here, a positive divided by a positive here is a positive. So it should be, the graph should be way up here at the top of the asymptote on the left side. Then I check the right side. The right side, I'm underneath the x-axis for the denominator, so it's negative. The numerator is still positive. So now I have a positive numerator divided by a negative denominator, which is going to be a negative. So on the right-hand side of that asymptote, it's going to be down at the bottom. So let's take a look and see if that's the case. Oh, whoops. Our graph is right here. So on the left side, it's supposed to be positive. It is. On the right side, it's supposed to be negative. It is. All right, folks. So that was